So now that we have an understanding of a real practical application for an exponential function, let's get even more general. Let's generalize because that's what we do in algebra class. Is we'd like to know. Well, first of all, there are all kinds of exponential functions besides those related to simple interest. There's of course something called compound interest, and then there's like exponential growth for bacteria. Bacteria grow at an exponential rate. Viruses spread at an exponential rate. Carbon-14 dating. We lose the mass of carbon-14 at an exponential rate. That's known as exponential decay. So let's look at a more general version of this formula that we came up with regard to simple interest. By the way, the reason this one was called exponential is because the number of years was an exponent. So let's generalize. Some of you are probably missing your old friends x and y. So I'm going to go ahead and rewrite this as y equals a times b to the power of x. And that guy is, this is known as an exponential function, and it's both exponential growth and exponential decay. Let's see here. So let's see if we can relate these things. You'll notice that the a and the y are kind of related. The y is the final amount, just like a was. Over here, this little a and the p are related. The p was the initial amount, and so is this little a. And then here, we're this base, 1 plus r, which is being raised to the power of t. Now we just call it b, and that is the base of the power. And then, of course, we have our old friend x, and x is the the t. So these guys are we're just swapping those. So now we could have an exponential function that could represent all kinds of practical applications that looks a lot like the one that we generated from simple interest. And again, as functions go, y is a function of x. We go ahead and we put in values for, we put in something into x, and then we get something out over here. Whatever the y value is, that's what comes out. Just a reminder from the concept of composition of functions, that's how they work. Functions are sort of like magical boxes. You put something in, and then the function does its magic, and then you get something out. And in our case, we are usually putting x in and getting y out. So this is a classic function, and it just happens to be new to us, the exponential function.